Gracias, Cedeño, Santibáñez, Cedeño de nuevo y Lavalle. Los jueces son el niño Mariscal, la niña estudiante de España y el que habla. Así que vamos a comenzar con el tema Free Torsional Vibration of a 30-meter length ship propulsion system. Adelante.
Good morning, everybody. We are the group number 1, and we are going to talk about free torsional vibration of a 30-meter length ship propulsion system. So, my name is Javier Yumikinga, and my partner is Jens Anunga. What is torsional vibration? The torsional vibration is a typical characteristic of all rotative mechanisms, and it is caused by the variable torque produced by the cylinder's rotation. So the propulsion in our area is usually generated by two elements, the propeller and the engine. So they are cause the vibration problems. Yeah. Our objective is calculate the first 4 frequencies of a propulsion system of a real 30 length ship. And why do we calculate the first 4 frequency of our system? Because when the excitation frequency is equal to the frequency of the system, the resonance occurs, and this resonance is very dangerous for our system. So this can fracture a section of our shaft. Now I am going to show our agenda. First, we are going to explain how to model a propulsion system to a linear system with disc and springs. So we will model the engine, we will model the reductor gear, and the flange shaft and propeller. Second, we are going to explain how to apply the Holzer method to obtain the estimates. And finally, we are going to explain the results and conclusions. Holzer method. The Holzer method is usually used to calculate the natural frequencies of a linear system. So, we need to model our real system to a linear system with disc and torsional stiffness, like this. And here we have the engine, the line model engine. Here we have the reductor, and at the end we have the propeller, like this. So how did we model the engine? First, we select a Caterpillar C18 engine with 6 cylinders in line. You can see in this picture 1, 2, 3, 4, 5, and 6 cylinders, and this is a real engine that we use for our project. So for model the propulsion system to a line system, we need the inertia of each component of the engine. So the components of the engine are the viscous damper, those 6 cylinders, and flywheel. So in this picture we have the inertia and torsional stiffness. And this picture is provided by the manufacturer. And finally, we have the engine, real engine, and here we have the line model engine. So here we have the viscous damper. Those are the cylinders, and this is the flywheel. And between of to this we have the torsional stiffness. Now,
well, continuing with this position, I explained is the reduction gear. But this is the reduction we use in our system. But this is the real reduction gear, and the brand is ZF. Yeah. In this picture, we can see is the pinion. Here is the gear. This is the flange, and this is the clutch. Well, in this picture, this is the same system but simplified. So this is the pinion, gear, and the clutch and the flange. But the manufacturer doesn't give the inertias, but we need to calculate. How? We use the three equation. This is the equivalent torsional stiffness. Yeah. G is the shear modulus of the carbon steel. GA is the section polar inertia, and L is the longitude of the shaft. Yeah. This to calculate the section polar inertia, we use only the diameter of the disc, and this is the mass inertia. We use the mass of the disc and the diameter of the disc. Well, this is a system, but we need to this transform in only this. For example, this is the flywheel. This is the pinion, is the gear, our clutch, and the flange. We use the gear ratio is 4.188. Yeah. How we next calculate this inertia? We have two new discs. This is in the gear and the clutch. Well, now we do the calculate inertia of the flange, shaft, and the propeller. Well, these have to the dimension now. For example, the flange, the dimension, the diameter externus is 28.5 centimeters. Now, the shaft is the diameter external is 11 for 43 centimeters, and the propeller is 1.37 meter. Yeah. We can see that the dimension of the shaft are not negable. We use to calculate inertia, and plus the stiff part, the inertia to the propeller and the flange. Right. In this picture, for example, in inertia to the flange, we use to calculate inertia in the flange plus the stiff part, the inertia of the shaft. In the inertia of the propeller, we do the same, but we use this factor is the aerodynamic effect. He have the inertia of the flange and the propeller. Well, in the method we use to calculate the natural frequency, we use the Holzer method. But this method, the characteristic of this method, we have two equations. The first equation is the recursion equation and the Chet equation. Well, we use the recursion equation we use to determine the modulus shape. Well, in this equation we have the omega, which is the frequency, n is inertia, and k is the torsional stiffness. Yeah. In the Chet equation we use to determine if omega is a natural frequency. Well, in this table, in this chart, we have the components and the inertia. We can see the inertia of the flywheel. Its inertia is very large, and the second is the propeller. Yeah. In this chart, we use the Holzer method. Yeah. In this part, we have all elements in the system, and here is inertia. Well, and this is the modulus shape. Well, this is the value of the frequency. Yeah. This method is iterative because we change the frequencies. Well, in this is the check the equation. Well, when this value is approximate to 0, we say that this frequency is natural frequency. Well, in this table we have the 4 frequency. The objective was that to calculate the 4 first frequency. Yeah. Well, in this picture we have the model shape. Well, in this X we have the number of the disks, and here the amplitude of the disk, the amplitude of the vibration. Well, we can see that the first model we have only chain of the same. The two chains, the three chains, and the four chains of the sine. Well, this model we use to determine what frequency is. For example, the four frequency we have in the 4 modes, we have 4 chains of the sine. Well, then they calculate the natural frequency to plot the frequency of the system when the frequency of the engineer. Well, this as the frequency of the engineer. This is the frequency of the system. This is the first frequency. This is the second frequency. Well, this is the harmonics of the engineer, and this is the major critical. And here we have the engineer have 1,800 RPM. Well, in this X we have the RPM on the engineer, and if the frequency in cycle per minute. Well, when two frequencies, the natural frequency and the frequency of the engineer intersect, we have the phenomenon in the resonancia. Well, in conclusion, well, then the model, the engineer and gear and clutch, the propeller shaft, well, so, yeah. Then the model to calculate the natural frequency, but we say that this model this system don't have the problem with the vibration, because the natural frequency don't intersect with the major critical of the engineer. This is all. Thanks.
Okay, thank you.
Any question?
Question, please. Hi. Which frequency do you think is the best in your calculations?
O sea, ponla. So the best situation is when the major critical intersect when whatever this frequency. For example, in this case, don't intersect. So this exercise don't have problem with the vibration, but the situation, the dangerous situation, is when this curve intersect whatever the natural frequency. Other.
Measurements or experiments or just theoretical calculation?
This is theoretical calculation. Any question?
Could you compare that?
What?
Could you compare that with a real data?
So this we calculate now this real sheet. So for example, the engineer is real, the reductor is real. So I compare it with the.
Good morning. Good morning, everybody. My name is Miguel Engracia. My topic is design of a tourist boat for the Malecón 2000 Foundation. Okay. My objectives. Okay. Number 1 is design of tourist boat for the Malecón 2000 Foundation. Okay, and number 2 is this design must the novel and innovate. Okay, in number 3, explore new technologies. Okay, and the requirements for this project is total distances 6.1 kilometers in a time of 2 hours. And number 2, capacity to transport 15 passengers. In number 3, navigate along the Guayas River. Okay.
Are you sure about the time? 2 hours for 6.1 kilometers? The requirements?
Yes. Yes. Okay. This is the itinerary. Itinerary must meet the ship in a usual day. Okay. The itinerary. Okay. The boat relays seven travels in a usual day. Okay. Dingat food supply for tourists. Okay. The abastecimiento is by drink and food supply for tourists. Not is for combustible, etc. Okay, the travel relatively short. The space used for dancing, drinking, fast food. For this by placing 1 or 2 bars. Okay. And most space will be used on it to admire the city of Guayaquil. Okay. See. The tour includes a path parallel to Malecondo's Mill, beginning in the spring that is near the monument to the donors, to the north to Cerro Santa Ana, returning to the foot of Malecondo's Mill, so the Crystal Palaces, and back again to the place of the apartment. 6.1 kilometers in a time 2 hours. Okay. See. Okay, design. For the design of these ships, data taken from a number of vessels with similar characteristics. 21 vessels with similar characteristics, obtaining the following main dimension. See. Okay, hull shape. These forms were generated in the modeling program Rhinoceros 4, taking into account innovative design requirement. Okay. You can see the form unusual in this but the length. Okay. Hull shape. These forms were okay. This form. See the hull shape aft. Okay. Vamos. Dale. Of the hull form obtained the following data in the program MaxSurf. Displacement, volume, draft of the vessel line, immersed, etc. Blood coefficient 0.47. For calculation of total resistance and power of our boat was used hull speed program module MaxSurf, obtaining the power required by our boat. For a maximum speed of 20 knots, the total resistance is 123.9 kN, and power is 1,700 708 HP. Okay. Dale. Okay. Propulsion system. This boat has a azimuth system, a marine propulsion that use electrical drive unit mounted on an strail propellers covered for metal shaft. Advantage of this system: excellent dynamic characteristic and maneuverability. Does not require long lines of axis, rudders, reducers, or reductors, cross bow propellers, or variable pitch propellers. Okay. This is the scheme this system. Okay. Engine characteristics. Because the hull shape, we need of this engine as azimuth with the following characteristic. We have two engines with 651 kW. Design factors inside. The design should facilitate the visibility from inside the nave of the seat around it. Should also be noted in form totally of the ordinary and force the necessary comfort to the crew. Okay. Design of superstructures. The shape of the superstructure to allow visibility of the city. Okay. Dale. Appearance of the ship. Structural. We have the structures keel, bulkhead, transversal in the principal deck, and secondary deck in the bottom transversal and distribution. Okay, this is the hull in my design, and this is equipment in the hull. Okay. We can see the propulsion system azimuth. We have two azimuth engine. Okay. Okay. This is engine room, and this is bar. This is living room and full tank. Okay. Sí. Sí. Okay. Economic analysis. Cost during construction. During construction, the armador value of the boat. Two aces, the vessel, the project has been separate in groups. Each group covers a specific area. We have structures. This is group 100, and this is group contain these parts, okay? Forro, planchaje, cubierta principal, planchaje segunda cubierta, planchaje en fondo, subtotal, and group 100 is this value, okay? We have group number 2 is propulsion 200, and we have 2 motor azimut Tursums GT 2000, the
3 minutes left.
subtotal 200 is this value, okay? And number 3, system electric, subtotal is this value, okay? Then electronic and navigation, okay? This is group number 4, subtotal in this group is this value, circuits and systems, okay? This is the group number 5. Subtotal in these values is 30.30, etc. This value, okay? This is the value of the total design, total project. Following is the analysis of loan repayment to the bank, assuming an 18% loan value to build to the but to 15% interest 5-year term. Okay, totals 15% and 35%. Okay, and now we analyze the benefits that we'll have our bought in a year with the following values according to the service provided. Okay, service and period of the time. Okay, and the total values is in the year is this value. Okay, now we analyze at the cost for losses will have our board to create salaries, maintenance, full, etc. Okay, cost total. This is okay. Then performance the economic analysis to determine the value of bound, where we get the following table of values. Okay, in the total is this for the 15% and the 35%. Okay, then remembering that when the value of the bound is 0, give the value of tier is that 28.18%. Okay. The reason cost benefits is this value, where you can see that the value of ratio is greater than 1, which gives you an idea or period economically feasible. Okay. This. Thank you.
Okay.
Yes.
Thank you.
Good morning. I am Stephanie Cedeño, and I am to give you an overview about the preliminary design of a general cargo barge of 35 meters in length. On this presentation, I am going to explain the requirements and dimensions. These requirements are based in the ship owner requirements, the general arrangements, the structural analysis. Then I'm going to show the general characteristics of the propulsion system, the synthesis of economic analysis, and the conclusions. Okay, the requirements. In some tourist companies are building playgrounds on the Santai Island, and they need a ship, a barge, which can transport people, workers, heavy machinery and construction material to the island. This island is located in front of the Malecon 2000. Okay, the barge has to transport these things 2 kilometers per trip. So from their dock to the island, the Santai Island. Okay, to obtain the dimensions, I made a linear regression with some dimensions of the typical barges. Okay, and another of the main requirements of the ship owner, it was the length of the ship. It has to be 35 meters. So with the 35 meters, I enter on those graphs, and I obtain the breadth and the depth. So these are the values, the results. So this is the model, the hull in the main dimensions in Rhinoceros program. For the general arrangements, I have the tanks under the deck. I have 12 tanks with 15 tons in each tank, the 2 fuel tank, the grey water and wastewater, and in aft part, and the castle. So to make the structural analysis, I used the Detnorske Veritas rules for classification of ships, and I made the all calculations. In this as I said at the beginning, in this presentation, I just going to explain an overview. So I don't include the details because there's no much time. So this is the structural, the mid section, and the longitudinal bulkhead, which avoid the enter of water if there is an impact or an accident. The longitudinal stiffeners, which provide the reinforcement of the ship, and some transverse bulkhead to reinforce the ship. So those are the thickness of main deck, the side plate, this side plate, the bottom plate, the longitudinal stiffeners, and the longitudinal bulkhead, and the transverse bulkhead. The propulsion. To make the propulsion, I use the Holtrop methods. So the velocity, there's not a problem, because in the main requirements they don't care about the velocity, because it's a small distance. So I estimate the velocity on 10 knots, and the power calculated, it was 380 horsepower. So to install it, there must be two engines and 200 horsepower each one. And these two engines are Yamaha, the brand Yamaha, and the fuel consumption is 81 liters per hour. Sorry. So to make the economic analysis, and I had to include a huge list. So I didn't include on this presentation, but the huge list is resumed in the cost of the barge. So in the list, I include the navigation and rescue equipment, these two engines, the stiffeners, the total cost of the construction, the welding, and everything that I need to build to make the barge. So the total cost, it was more than 100,000. So the incomes to the ship, it was the passengers. The passengers have to pay 50 cents. 50 cents it would be to go and go back. And the cargo, it would be the heavy machinery, the construction material, and monthly we have this income. So the annual income, it will be this. So expenses, the salary of the crew, and the fuel expenses. There is not much because it's only 2 kilometers distance, and the maintenance it has to be each 2 years, and the license, the papers, the document, the files, and the total expenses is those. So to make this economic analysis, I use an Excel sheet where I enter the values, the main values that I am going to calculate. So that sheet produce this square, this table. So for each year, I assume that the investment of the investment it would be 15%. So the loan with the bank, it would be the another percentage. So at the end of the calculation, I did for two values of investment. So I obtained two values of VIN. The VIN is a value which can explain. It's an indicator, a financial indicator, which measures the flow of future incomes and expenses. So in this case, I have two. So when the VIN is larger than 0, I can see in this case it's larger than 0, so I can say the project is reliable. So the VIN measures the reliability of the project. The TIR is the discount rate of an investment project. So in this case, we can conclude the project is reliable. So the conclusions, and the design of the barge was based on the requirements of the ship owner. In this case, the design meets the requirements of the ship owner, and if the ship owner wants transport another thing, the design adapt to that requirement. And besides its main use, the boat can provide transportation service of potable water to rural areas of the Gulf of Guayaquil. So, as I said before, the boat is designed to give some service, not just transport a person or just transport cargo. So, can transport a liquid or potable water to rural areas which they don't know, where they don't have that service. So finally, this project is economically profitable. Thank you.
To navigate